Hello, Physics 2. Here we are. This is Chapter 35, Homework 6, and this is Problem 2. So we've got an RC circuit. The capacitor is not charged at the beginning, and the switch is open. So what we're going to do is we're going to close the switch at time t equals 0, and then figure out what's going on here. So the things we're trying to figure out, part A, what resistor should we choose? So let's see. Nope, wrong tool. Step, what are we trying to figure out? For part A, what resistor should we choose? So R is going to be question mark, and the units for R are going to be ohms. For B, if we close the switch at t equals 0, when will the voltage across the capacitor be that? So when is a time. So t is question mark seconds. And then C, when will it be 12 volts? So we're also looking for a time in seconds. So for part A, what resistor should we choose to give the circuit a time constant of 0.35 seconds? All right, we've got a formula for time constant. Tau is equal to RC. We know the tau we want. We know the capacitor we have. We're just trying to solve this for R. So that's going to give us R is equal to tau over C. So 0.35 seconds over 25 micro, that's a microfarad, which is 0.35 seconds over 25 times 10 to the minus 6 farads is what you need to put in the calculator. And if you do, you're going to end up with 14,000 ohms, which is probably easier to write as 14 kilo ohms. So we've got that. Part A, very, very easy. Parts B and C, a little bit trickier. And the way I'm going to do this is once we do the work for Part B, Part C is going to be easier. It's just going to be plug and chug. So we're trying to figure out if we close the switch at this time, when will the voltage across the capacitor be 6 volts? So the formula we're going to use is voltage across a capacitor is equal to V naught, so that's the voltage of the battery, times 1 minus E to the minus T over RC. I'm just going to write this as tau. So minus T over tau. And the thing we're trying to solve for is time. So first things first, let's divide both sides by V naught, and that's going to give me V sub C over V naught is equal to 1 minus E to the minus T over tau. And then a little bit more algebra is going to give me, so I'm going to switch, I'm going to add E to the minus T over tau to both sides, and I'm going to subtract V sub C divided by V sub naught. And that's going to give me E to the minus T over tau is equal to 1 minus V sub C over V naught. So now pause, let's reflect. The thing we're looking for here is time. So I've got to do the algebra that gets me to time. The tricky thing is I've got that up in the exponent of E. I have E to the something power that's got time in it. So I need to get rid of that. The way you do this from this point is you just take the natural log of both sides. If I take the natural log, let me actually rewrite that just to make it clear what's going on. So I'm going to have natural log on the left, E to the minus T over tau is equal to natural log 1 minus V sub C over V naught. On the left side, if I take the natural log of E to the anything, I get the anything. So on the left side, I'm now going to have, let me go this way because I'm running out of space, minus T over tau is equal to, over here I'm going to keep the natural log 1 minus v sub c over v naught. So now just a little bit more algebra. Basically, I'm going to multiply both sides by negative tau, and that's going to give me a formula I can use for the rest of this. That's going to give me t by itself on the left side, which is what I want, is going to be equal to negative tau times natural log 1 minus v sub c over v naught. So we've got that, so we just have to plug in the numbers we have. So time is equal to negative tau. Remember, tau is 0.35 seconds times the natural log of, all in parentheses, 1 minus v sub c. Remember in part B, we want to know when will v sub c be 6 volts over v naught. V naught in this case is 18 volts. The volts cancel. So this is really equal to minus 0.35 seconds times the natural log of 1 minus 6 over 18 is the same thing as 1 minus a third. So the natural log of 2/3 ultimately is what I have here. And if you do all this, you're going to get 0.142 seconds. So there's my answer for part B. And then I'll finish this, but I've run out of space. So what I'm going to do is let's keep this formula in mind. This is the formula we're going to use. We'll make a new page. So yeah, the formula we're using, so here we are in part C. Time is equal to negative tau times the natural log of 1 minus v sub c over v naught. So let's see, where did all that crap come from? V sub c minus v naught, alright. Which means time is equal to negative tau again, 0.35 seconds, times the natural log of 1 minus v sub c in part C is 12 volts, divided by 18 volts. So I've got more room. Let me write the whole thing out. 0.35 seconds times the natural log of 1 minus 12 over 18 is 2/3. So minus 0.35 seconds. Natural log of 1 minus 2/3 is just 1/3. So if you do all that, you get 0.385 seconds. So hopefully that helps.